EFI versus carburetor comparison. The carburetor is a pressure-driven mechanical device that delivers fuel based directly upon the airflow needs of the engine. It's a very simple, cost-efficient component and has been optimized greatly since its inception. However, its downfalls begin with its inherent design. It's somewhat wasteful and cannot create smooth and steady delivered air-fuel ratios across a broad band of operating ranges. The biggest reason for waste is that the fuel has to travel a very long way to the combustion chamber and relies solely on airflow to move it. If airflow becomes stagnant or has to make sharp curves, the fuel will fall from suspension and pool and adhere to the intake manifold walls. This creates uneven fuel delivery patterns for every intake stroke, affecting performance and emissions. The carburetor cannot be calibrated very easily to cover wide ranges of operation because fixed orifice jets are typically used to calibrate fuel delivery. The engine may end up with rather lean conditions in certain ranges and rather rich in others. It's difficult to find a happy medium with no trade-offs. Altitude compensation must be made for carburetors as well. The higher in elevation, the less oxygen present, and jetting needs to be altered with smaller orifices to reduce fuel delivered. As opposed to the carburetor, fuel injection provides a wide range of predictable air-fuel ratios, which greatly improves engine performance and emissions. The fuel is administered as close to the intake valve as possible, and is timed to inject fuel only when the intake valve is open. This is important because airflow into the combustion chamber is taking place, and the fuel is not exposed to the intake manifold for enhanced atomization, where it can often become stuck to the walls and never even make it to a cylinder. With port injection, the fuel is atomized as it leaves the tip of a high-pressure fuel injector. Liquid fuel doesn't burn, it's the vapor that burns. The better the fuel can be broken into smaller droplets, the more likely it will vaporize. The fuel will then easily ignite and burn more completely. If the majority of the fuel is reaching each cylinder, then there will be little waste, yielding more power and torque from idle to redline for a given fuel quantity. Altitude compensation is made instantly upon key on with EFI through the engine's manifold pressure sensor. This scales fuel delivery based on current ambient pressure for seamless operation.